Hi friends.
So hello guys, welcome to IIT. So first of all, please like, share and subscribe and comment also. So please support guys. So first of all, we can discuss about periodic table of the elements. So introduction, you must have visited a library. There are thousands of books in a large library. In spite of this, if you ask for a particular book, the library staff can locate it easily. So first you ask a particular book, like for example chemistry book. So then the staff will easily identify where the book is, in which block the book is. So now you can take the book. So you can think how it possible. In library, the books are classified into various categories and subcategories. They are arranged on shelves accordingly. Therefore, location of books becomes easy. So let come back. Us come back to chemistry. Most of the matter that we see, touch, and feel is made up of compounds. There are millions of such compounds existing presently. You will be surprised to know that compounds are formed as a result of various permutations and combination of only about 110 odd elements. To study properties of these elements and their compounds is a tough task. So, how then was this task simplified? This task was simplified by simple classification of elements into a few groups. Instead of studying each and every element or compounds, we just learn the properties of groups. The atoms was made by different scientists to classify elements based on their properties. So, necessity for classification of elements. Following are the reasons for the classification of elements. The classification may help to study them better. The classification may lead to correlate the properties of the element with some fundamental property. So that is characteristic of all the elements. The classification may further reveal relationship between the different elements. So early attempts for classification. Greeks classification. The ancient Greeks suggested that all matter consists of 4 elements only: earth, air, fire and water. But their idea could not be supported by the experiments. Classification on the basis of valency. Realizing the importance of valency in chemistry, an attempt was made to classify elements on this basis. The monovalent elements were classed together, and so were the divalent ones, the trivalent ones, and so on. However, such classification suffers from the following drawbacks. Several elements have variable valency. Example, iron has a valency of 2 and 3, copper 1 and 2, tin 1 and 4, lead 2 and 4, etc. Makes the position of such elements uncertain. Second point, such classification does not explain the diverse nature of elements having the same valency. For example, both sodium and chlorine are monovalent, but they are quite different from each other. In chemical behavior, sodium is a strongly electropositive metal, whereas chlorine is a strongly electronegative non-metal. Electropositive element easily donates an electron. Electronegative element easily accepts an electron. And one scientist came to the world, revised classification, metals and non-metals. By the late 1860s, more than 60 chemical elements had been based on similar physical and chemical properties. Revisal and early chemists classified the elements into metals and non-metals. First point, elements which were malleable and ductile, good conductors of heat and electricity, and possessed static metallic luster were named as metals. Second point, elements which were brittle, bad conductors of heat and electricity and did not possess metallic luster were named as nonmetals. Certain elements such as antimony, arsenic, boron, silicon and tellurium resembled metals in some respects and nonmetals in certain respects and were therefore metalloids. Reason for rejection of classification into metals and non-metals. First point. Some of the elements behave both as metals and non-metals. Second point. The elements were divided only into two broad categories, which does not help much in the study of elements. Dalton's classification. In 1808, John Dalton published the first list of atomic weights in his table of relative atomic weights of the ultimate particle of gases and other bodies. He changed chemists' ideas from a qualitative to quantitative basis. I started the chemical revolution during the 19th century. Major contribution leading to the development of modern periodic table, double lineal classification. In the year 1829, John Wolfgang Double-Lineal, a German scientist, was the first to classify elements. He grouped the elements that showed similar chemical properties into groups of three called triads. The distinctive feature of a triad was the atomic mass of the middle element. Examples of double lineal triad: element lithium, sodium, potassium. Lithium atomic mass 6.9 approximately, sodium 29, potassium 39. Average equals to 6.9 plus 39.0 by 2. So then we will get 22.95. We can take another example: chlorine, bromine, iodine. 35.5 approximately, 79.9 approximately, 126.9 approximately. So we can check now. 35.5 plus 126.9 by 2 equals to 81.2 average. Signification of double lineal triads. This classification of elements in triads had greater signification in predicting the atomic mass and properties of the middle element. However, only a few elements could be arranged in such triads. Defects means the wrong statements of triad classification. Quite a large number of similar elements could not be grouped into triads. A large number of similar elements could not be grouped into a triads. Okay? Example: iron, manganese, nickel, cobalt, zinc and copper. Second point, it was possible that quite dissimilar elements could be grouped into triads, as double lineal failed to arrange the then known elements in the form of triads. His classification was not very successful. For example, carbon 12, nitrogen 14 atomic number and oxygen 16 atomic number. Atomic mass. Oxygen 16 atomic mass, nitrogen 14 atomic mass, carbon 12 atomic mass can form a triad, but their properties are entirely different from each other. Okay? IIT-CHEMISTRY classification. The next IIT-CHEMISTRY classification. The next reported attempt was made by a French geologist, IIT-CHEMISTRY in 1862. He arranged the then known elements in order of increasing atomic weights and proposed a cylindrical table of elements to display the periodic relationship of properties. He observed that elements with similar properties arranged in a vertical line from the center of spiral. However, this did not attract much attention. So guys, this is today's video.